Let's see if we can solve our basic plug and chug binomial problems using the probability notation that you're going to most often see. Here's a situation where you have n is 6, so there's 6 trials, p is 0.2, there's a probability of 20% on each trial that you're going to succeed, and you want to find p of x equals 4. Now what that means in English is what is the probability of exactly 4 successes. So x equals 4 is exactly 4, and we're always looking for probability of success, our p here. Whenever we have an equal sign, we're looking for an exact number, we're always going to use our binom PDF. So we're going to go to our second vars, and in my calculator, that's going to be at A, binom PDF, and we're going to type in n comma p comma x. So n comma 0.2, so 6 comma 0.2, and then exactly 4 successes, so x equals 4. Just drag that over here. And so then our answer, our probability of exactly 4 successes is going to be 0.015 if you were to round it off to 3 digits. Next one, it says n is 6, p is 0.2 again. What is the probability x is less than or equal to 3? And what that's saying is what is the probability of 3 or fewer successes? Now if you remember, 3 and fewer, or any number and fewer, is a function in our calculator. It's that binom CDF. So we go to our second vars, and in my case it's under B, binom CDF, otherwise you can just scroll down and find it. We always do n comma p comma x, and x in this case is always the number for which is the highest one in the list, so it's 3 or fewer, so 6 comma 0.2 comma 3, and we hit enter, and it says according to this there is a 98% chance, or a 0.983 probability of 3 or fewer successes under these conditions. So it's very likely there's going to be 3 or fewer successes. These next ones get a little bit complicated, and to do these I'm going to recommend writing out a list of numbers and then drawing around it. So it says what is the probability, that's what the big P stands for, probability that x is greater than 3, more than 3 successes. To do this, I have 6 trials, 0 through 6. I'm going to do 0, 1, 2, 3, 4, 5, 6, and I always start my list at 0. And the numbers that I want to find is more than 3. So more than 3 does not include 3. More than 3 would start at 4, include 5, and include 6. I want to know the probability of 4 plus the probability of 5 plus the probability of 6 being rolled. Now, the way that I do that with my calculator is not by typing in 6, because I am not going to be able to do that. Instead, I take the other side of this list. If I break it in half, if I break this list in half, I take the lower end, 3 and down, and I find the probability of this. And here's why. If I were to find this probability here of 6 comma 0.2 comma 3 and say that it's 0.983, then I can use that to figure out the other side. So 0.983 is my probability of success on the left. There's a 100% chance that I'm going to get somewhere between 0 and 6. So if the probability altogether is 1 for this whole list, and the probability of the left side is 0.983, I can take 1 minus 0.983, and that's going to give me my answer for the highlighted region of 0.017. So over here, this probability is 0.017, and that would be the answer to the question, the probability of more than 3 successes. We're going to practice a few more like that. Same situation, it says probability that p is less than 2, probability of fewer than 2 successes. Same idea, I'm going to get in that habit of always making that list of numbers. And in fact, just to show you a little shorthand, there's the numbers that I really want to have is always the numbers around my x is less than, x is greater than value. In this case, x is less than 2. So I do 0, 1, 2, 3, and then I kind of throw some ellipses in there because it doesn't really matter until I get to my end. Now I'm going to highlight in green what I want. Fewer than 2. So that means fewer than 2 would mean 1 and down. So 1 and down. Now the 1 and down, we do know how to find that in our calculator. We do the binomial CDF, just like we've been doing, and we would just type in for x 1. And we get that probability here, that 0.655, and that's going to be our answer. So the 0.655 right here is the probability of getting a 0 or a 1. Next one is again a complicated one because we are going greater than. So the number of interests here is that 1, so I'm going to do my list 0, 1, 2, get one number on either side, and then I can just skip up to my 6. The numbers of interest, I want to know probability that x is greater than 1, more than 1, so it does not include 1, it starts at 2 and goes up. I know I can't do that by in my calculator, so I split the list in half, and I'm going to find the left side of this list, the probability of 0 or 1. And I can find the probability of 1 and down, which is what I had done earlier, binomial CDF of 6.2, 1. And that finds the probability of 1 and down. So my probability of success over on the left is 0.655. That means that if the whole probability is 1 of getting some number, the probability of ending up in the green is 1 minus 0.655. So 1 minus 0.655, and what that's going to give me is 0.345. So the probability, the answer to this question, probability of landing in the green of having more than one success is 0.345.